Good morning. Let us start Unit 4. Okay. Unit 4 in Differential and Integral Calculus. Differential and Integral Calculus. See, in Unit 4, we have four main concepts: length of the plane curves, length of the plane curves, length of the plane curves, volume of solid of revolution, areas of the surface of revolution. These are the first three main concepts. And we have theorem of Pappus. In theorem of Pappus, we have volume of revolution and surface of revolution. Okay, this is very important concept of Unit 4. 100% you can expect a long answer as well as a short answer. Two short questions also in some of the question papers. Two short questions in some of the question papers as well as one long answer from this concept. Okay. Before entering into this concept, before entering into the problems, we need to know the formulas related to length of the plane curves. Okay. First, Cartesian equations. For Cartesian equations means equation of the form y is equal to f of x or x is equal to f of y. Okay. For y is equal to f of x, the length of the arc is given by ds by dx is equal to under root 1 plus dy by dx whole square. For the curve y is equal to f of x, ds by dx is equal to under root 1 plus dy by dx whole square. For the curve y is equal to f of x. Arc length, what is arc length? Arc length of Cartesian equation. Arc length of Cartesian equation is given by integral a to b ds by dx into dx. ds by dx into dx. That is integral a to b under root 1 plus dy by dx whole square into dx. This is for y is equal to f of x curve. Whereas x is equal to f of y curve, arc length of Cartesian equation is given by integral a to b under root 1 plus dx by dy whole square into dy. This is the formula for arc length of Cartesian equation for the curve x is equal to f of y. Okay, this is first formulas you have to remember. And next, for parametric equations. For parametric equations. For parametric equations means the format will be like x is equal to function of t and y is equal to function of t. X is equal to function of t, y is equal to function of t. And what is the length? Length ds by dt is equal to under root dx by dt whole square plus dy by dt whole square. Under root dx by dt whole square plus dy by dt whole square. This is the length formula for parametric equation. Whereas arc length of parametric equation is given by integral a to b ds by dt into dt. That is nothing but integral a to b under root dx by dt whole square plus dy by dt whole square into dt. This is arc length for parametric equations. Okay. Now formula number 3 for polar equations. For polar equations. Polar equations means equation will be in terms of r and theta. Okay. Polar equation means equation will be in terms of r and theta. Okay. Now length ds by d theta is equal to under root r square plus dr by d theta whole square. under root r square plus dr by d theta whole square. What is arc length of polar equation? Arc length of polar equation. Arc length of polar equation is given by integral a to b ds by d theta into d theta. That is nothing but integral a to b under root r square plus dr by d theta whole square into d theta. Okay, these are the three formulas which we have to remember for length of the plane curves. Now, let us enter into the problems related to length of the plane curves. Let us see question number 1. Find the length of the arc of the parabola. X square is equal to 4ay measured from the vertex to one extremity of the latest rectum. Okay, this is question number 1. First, what is given? If the question is given like this, length means we have to apply the formulas which I have given in our introduction. Okay, given x square is equal to 4ay. Okay, implies y is equal to x square by 4a. What is the formula for length here? The equation is given in y in terms of x. That is the reason length of the arc will be integral a to b ds by dx in x, with ds by dx is equal to under root 1 plus dy by dx whole square. Okay. Now, first we have to find ds by dx. Before finding ds by dx, what we have to do is we have to find dy by dx. Differentiate on both sides with respect to x. Implies dy by dx is equal to 2x by 4a, means x by 2a. X by 2a. This is dy by dx. Okay, now ds by dx is equal to under root 1 plus dy by dx whole square, means that is equal to under root 1 plus x by 2a whole square. That is nothing but 1 plus x square by 4a square. Now, this is the length. Now, what we have to do? We have to find arc length, length of the arc of the parabola. Okay, arc length is given by integral 0 to 2 pi. The limits are from 0 to 2 pi. Okay, under ds by dx into dx, that is equal to 0 to 2 pi under root ds by dx we got as 1 plus x square by 4a square into dx. 0 to 2 pi, 0 to 2a, sorry, 0 to 2a, 2a. The limits are from 0 to 2a, 0 to 2a. 0 to 2a under root of 4a square plus x square by 4a square into dx. If we send this for 1 under root 1 by 4a square outside, it is 1 by 2a integral 0 to 2a under root x square plus 2a whole square I will write. We know one formula under root of x square plus a square into dx. Okay, that is x by 2 integration of under root x square plus a square into dx. X by 2 under root of x square plus a square by 2 sine h inverse x by a plus constant. This is the formula for integration of under root x square plus a square into dx. Okay. Next, I am applying for this. 1 by 2a x by 2 under root of x square plus in place of a we have 2a plus a square by 2 sine h inverse x by 2a sine h inverse x by 2a plus c. Okay. Limits are from 0 to 2a. Okay. 1 by 2a 2a by 2 upper limit minus lower limit. 2a by 2 under root of 2a whole square plus 2a whole square plus 4a square by 2 sin h inverse 2a by 2a. Lower limit is 0. That is the reason this is completely 0 minus lower limit. Upper limit minus lower limit. This is upper limit minus lower limit is in place of x0, this is complete 0. In place of x0, sin h inverse 0 is 0. That is the reason this is completely 0 for lower limit. Okay, now we need to do simplification. 1 by 2a, a under root of 4a square plus 4a square, 8a square plus 2a square sin h inverse 1. Okay, sending this also inside. A, this is 2 root 2 into a. 8 can be written as 2 root 2 by 2a plus 2a square by 2a sin h inverse into 1. Okay. Now this is cancelled and this is also cancelled. A root 2 plus a sin h inverse 1. We have sin h inverse x formula is log of x plus under root 1 plus x square. Okay, this is the formula for sin h inverse x. Now substituting here, sin h inverse 1 means sin h inverse 1 means log of 1 plus under root 1 plus 1 square. That is nothing but log of 1 plus root 2. Log of 1 plus root 2. Now substituting here. This is nothing but a root 2 plus a log 1 plus root 2. This is the length of the arc of the parabola. Okay. Once you can observe here what we did first. First, given curves will be given. For that given curve, we have to find dy by dx and this is the formula. After that, we need to find ds by dx. Substituting in that length of the arc and limits we have to write whether that are 0 to 2a, 0 to a, 0 to pi, 0 to pi by 2. According to the given problem, limits will be there. Okay. After that, integration. This is the integration formula. Substituting upper limit minus lower limit. And final simplification, we got this answer. This is the answer for the given curve and this is the length of the parabola. Okay.